Which of these three minerals could scratch glass? They might look similar, but one of them is a lot harder than the others. Hi, I'm Shaz. Welcome back to Crystal Detective, where I show you simple tricks to help you identify mystery specimens. In this episode, we're going to be looking at arguably one of the easiest and most useful mineral identification tests there are. It's the hardness test. The first thing to know about mineral hardness is that this test has nothing to do with whether a crystal chips, breaks, or deforms. It has to do with a mineral's resistance to its surface being scratched. To do this test, we're going to be using the Mohs Hardness Scale, which was invented all the way back in 1812 by Friedrich Mohs, and it's proven so useful that we still use it in the field today. The scale lists 10 different minerals in order of hardness. You can compare mystery minerals to any of these to figure out where it falls in the scale. So for example, a mineral at hardness 5 is going to be able to scratch anything from 4 below, but it won't be able to scratch anything above that. So the first mineral on the list is the softest one, and it is talc. You might know it better as talcum powder. Next up is gypsum, which covers your selenites and your satin spars, followed by calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, like rubies and sapphires, and finally at number 10, diamond. So let's look again at the three minerals I showed you at the beginning. If I were to arrange them in order of hardness, quartz would be 7, that would be the hardest that we have in the hand. Next up would be fluorite, and lastly, the satin spar would be at number 2 as a gypsum. Here are a few tips when you are performing scratch tests. First of all, choose an area of the specimen that you don't mind being damaged. It can leave a permanent groove if it does scratch. 2, make sure you wipe the specimen down after doing your test to make sure that you remove any powder residue that can confuse you. Sometimes the powder can look like a scratch, and when you take that powder away, there is no scratch there. 3, test your crystal in a few different directions. Some crystals have differing hardnesses in different directions. Kyanite is a famous example of this, and this relates to its crystallography, its internal structure. Lastly, bear in mind that a hardness level of a mineral can be affected by a few things, such as weathering, the age of the crystal, whether it's damaged, and whether it has a lot of impurities. So these can affect the outcome, and it's why we generally refer to crystals having a hardness range and not a set number. Let's do a few demonstrations. Have the 10 Mohs minerals lying around to use, and in that case we can refer to the common items scale. Now this is really useful for being in the field, or if you happen to be home and you just can't find anything else to work with. So both this chart and the hardness chart are available for download in my learning center for free. You can hop on over there and grab them after watching. So the common items include things like a piece of glass, which is around 5.5, your fingernail, which is around a 2.5, unless you have fingernails like mine, in which case they're a lot less, and a steel knife, which will be around 7. So while these might not be able to give you a perfect measurement, they're going to help you narrow down the field. Once you know what your mineral is, you can look up which minerals have that hardness, and you have another clue in figuring out what your mystery specimen is. Once